Welcome, everyone. I am absolutely thrilled you're joining me for this explainer. Today, we've got a really clear, overarching goal. We are going to demystify the incredible journey of raw, unrefined data and see how it transforms into truly actionable business intelligence and AI-ready fuel. So, if you've ever wondered how modern enterprises actually make sense of their massive, frankly, overwhelming data footprints, well, you are exactly in the right place.
It all starts with this one core question. How does raw data actually become business intelligence? Every single day, organizations generate massive amounts of fast-moving, unstructured, and honestly, pretty chaotic operational data. But here's the thing. Business leaders can't make decisions based on chaos. They need clean, reliable, and integrated insights. And the gap between those two realities? That is exactly what we're bridging today. Okay, let's dive into this. The really high stakes of getting your data architecture right can be captured by one simple truth. Good models turn raw data into trusted insights that power analytics, automation, and business decisions. Because without a good model, you just don't have trust. And without trust, your analytics and AI initiatives will literally fail to launch.
Here is our roadmap for today's data journey. Number 1. Why data modeling matters. 2. Bridging operational and analytical systems. 3. Structuring data for speed. 4. Modern data architectures. And 5. The semantic layer explained.
Kicking things off with Section 1, why data modeling matters. So the absolutely crucial point here is that data modeling isn't just about, pretty design. It is the rock-solid foundation for reliable platforms. This foundation relies on 5 core pillars: performance, quality, being analytical ready, being AI ready, and ultimately driving real business value. When a model is designed well, queries run faster, the data is trustworthy, and machine learning models are far more accurate. All of this converges into a single source of truth, giving organizations a much faster time to market and way lower maintenance costs.
Moving right along to Section 2, bridging operational and analytical systems.
To bridge these two totally different worlds, think of the data pipeline as a linear sequence, kind of like a literal journey. First up, we have OLTP. These are the operational systems, like your ERP or CRM, where the actual day-to-day transactions happen. Second, that data flows into an ODS, or operational data store, which gives us a near real-time integrated view of current data. Third, we use ETL or ELT processes to basically extract, transform, and load that data. And finally, it lands safely in the data warehouse for historical, integrated reporting and analysis.
Now, you might be wondering, why don't we just connect a BI tool like Power BI straight into the ERP system? Well, let me tell you, that's a disaster waiting to happen. You'd effectively crash the various systems that run your daily business. Running heavy analytical queries on an operational database literally starves the transactional systems that keep the business alive. Plus, ERP schemas are incredibly complex and super unfriendly for reporting. The data might be inconsistent, historical retention is usually tiny, and there's absolutely no single version of truth. That's why the operational data store acts as this clean, integrated layer, providing operational integration today and business intelligence tomorrow.
Let's get into Section 3, structuring data for speed.
Once the data has safely crossed that bridge into the analytical warehouse, it has to be physically arranged so it can answer business questions instantly. And this brings us to the two foundational analytical models, the STAR schema and the snowflake schema. Both models separate data into fact tables, which store the actual numbers and quantitative measures, like sales amounts, and dimension tables, which store the descriptive attributes, the who, what, when, where, and why. Think of the STAR schema kind of like a simple one-page restaurant menu. It's highly denormalized and incredibly fast to read, giving you fantastic query performance. The snowflake schema, on the other hand, normalizes those dimensions into related tables. It's more like a menu that forces you to flip to a glossary in the back just to see the ingredients. It definitely saves storage space and reduces redundancy, but it requires more complex jumps or joins to get your answers.
By pre-aggregating data across multiple business dimensions like time, product, and location into a multidimensional structure, kind of like a 3D cube, an OLAP structure takes those schemas to a whole new level. It allows a CEO to instantly answer a really complex question. Say they ask, what was the exact profit for laptops in Colombo during Q2? Well, the OLAP engine doesn't have to go and scan millions of raw transactions to figure it out. The answer is already calculated, ready to go, and retrieved in seconds.
To interact with these multidimensional cubes, analysts use some specific OLAP operations. Roll-up lets you aggregate data to a higher level, like zooming out from monthly to yearly sales. Drill down does the exact opposite, diving into the nitty-gritty details. And then you have these fast, agile actions. You can slice by fixing just one dimension, dice to select a specific subcube, or pivot to rapidly rotate the view entirely, just flipping the rows and columns. These operations mean users can seamlessly navigate complex hierarchies and view the exact same data from completely different angles, all with remarkable speed.
Now, what's really interesting about this next shift is Section 4, Modern Data Architectures.
Let's compare the traditional approach with the modern standard. So, the traditional data warehouse is highly structured, very schema-driven, and perfectly optimized for standard reporting. But it can be incredibly rigid. On the flip side, the Lakehouse architecture combines the absolute best of a data warehouse and a data lake. It handles both structured and unstructured data seamlessly, making it open, scalable, and pretty much the ideal foundation for modern AI and machine learning workloads.
Another vital modern approach is the Enterprise Data Vault. This is a highly scalable modeling approach built on 3 core blocks. Honestly, think of it like an airport transit system. First, you have hubs, which represent unique business entities, like your customers or products. These are your main airport terminals. Second, you have links, which capture the relationships between those hubs. So these are the transit trains connecting your terminals. And third, satellites, which store descriptive attributes and perfectly track changes over time. These hold all the individual passenger details. If an organization's top priority is massive integration across dozens of source systems, strict auditability, and full historical tracking, well, Data Vault is basically the perfect middle ground.
Alongside the Lakehouse, we very often see the Medallion architecture. This is a progressive timeline of data refinement. Data initially lands in the bronze layer exactly as it was generated, raw, totally unprocessed, sitting right at the base of the climb. Then it ascends to the silver layer, where it gets cleansed, validated, and conformed to business rules. Finally, it arrives at the absolute peak in the gold layer, heavily aggregated, optimized, and completely business-ready. The key takeaway here is that trust and data quality increase at every single stage of this journey.
Anchoring this back to true business value, the Medallion architecture ensures that these curated data layers actually lead to faster analytics, strict governance, and AI-ready structures. By the time that data hits the gold layer, it is totally primed for star schemas, OLAP cubes, interactive dashboards, and advanced predictive machine learning models.
And that brings us to our final stop, Section 5, the semantic layer explained. Think of the semantic layer as your organization's universal translator. It offers immense benefits by completely hiding the underlying technical complexity. That means everyday users don't need to know how to write complex SQL joins or understand confusing database keys. It allows them to focus entirely on the what and the why of their business questions, completely ignoring the how. It truly enables self-service BI, creating confident users, all while providing clean, well-defined metrics that AI copilots can easily consume. Here is a golden rule to live by. Business users should absolutely never query fact tables directly. The semantic layer acts as a protective shield and the ultimate single source of business truth. It defines metrics, relationships, and rules so that whether someone is using Power BI, Tableau, Excel, or some new AI assistant, literally everyone in the business speaks the exact same metric language. As we begin to wrap up this explainer, it all really boils down to one ultimate success formula: having the right data layered onto the right architecture, creating the right models and insights, empowered by AI, which leads directly to better business decisions. To summarize this entire journey one last time, we start with operational events generating raw data. That data quickly crosses the bridge, optionally passing through an ODS for near real-time operational reporting. It's then historically integrated into a robust data warehouse or a data vault. Next up, it's organized into highly optimized star schemas and multidimensional OLAP cubes for lightning-fast querying. And finally, it seamlessly surfaces through dashboards and machine learning platforms to drive actual, measurable business value.
I'll leave you with this final thought. Take a hard look at your own company's systems. Is your organization's data architecture a chaotic traffic jam of direct connections and painfully slow queries? Or is it a streamlined, well-modeled bridge perfectly ready to power the next generation of AI? Thank you so much for joining me on this explainer today. Keep learning and keep building better models.